Why are French snails the fastest? Less cargo. Alright, what's going on, Algebra Bros? It's Mr. C here, and in this video we're going to do an example involving the difference quotient. Alright, so let's get on with it. I'll go ahead and define the difference quotient for you. The difference quotient is an expression, I know it says equation here, but it's an expression that gives the slope of a secant line. And I feel really bad for my sister. C can't remember this stuff, but anyway, that's neither here nor there. But basically, if you recall from, say, like a geometry course, a secant line connects 2 points together, say like in a circle. Basically, the difference quotient tells you how to find the slope of a line that connects 2 points on the graph of a function. Now, I won't get into too much of the nerdy details there, but just know that if you plan on taking, say, Calc 1, that this is an expression that you'll work with extensively. In this video, I'm basically just going to show you how to work with the difference quotient expression, which, as you'll see, is an exercise in evaluating functions and then simplifying in a special way. Alright, so here is the expression for the difference quotient. First of all, this is a typo here. We're not going to say f of x equals. The difference quotient is this. It's a fraction, and in the numerator of the fraction, we're finding a difference. So hence, difference quotient. In the numerator, we have f of x plus h. So this is actually going to be one of the first things we do in finding the difference quotient. Once we do that, we're going to subtract off the original function f of x, and that's the second thing that we do. The third and final thing we do is we take whatever we get after the dust settles in the numerator here, and we divide it by h. So you'll see, or you're seeing now, that I have sort of these three steps outlined below the example, and we're using a particular function, namely f of x equals x squared plus 3, that we're going to find the difference quotient for. Alright, so let's go ahead and get on with step 1, where it says evaluate and simplify f of x plus h. So this is the first part in the numerator of that difference quotient. So let's start by writing f of x plus h. Now f of x plus h is really just asking you to take x plus h and plug it into all the x's in the function for f of x. Now you'll notice there's really just one x that we're seeing here. It is being squared. And that's where we're going to plug x plus h into. So I'll say this is equal to, instead of x squared plus 3, it's going to be x plus h squared plus 3. Now, in a lot of cases, if you have an opportunity to simplify via some algebra, you want to go ahead and take that opportunity. Now, for instance, in x plus h quantity squared plus 3, the power of 2 there is really telling us to FOIL. And that's something we want to do. It's going to help us out in our second step. So let's go ahead and write out 2 factors of x plus h. Don't forget the plus 3. And we'll FOIL the x plus h's together. So there's going to be x times x, giving us x squared, added to x times h. All right, here's where this is coming from. X times x, the f part, then the o part, then the I, and then the L part of FOIL. And so we're going to get, for the rest of this, plus hx plus h squared, and don't forget the plus 3. Now there are a couple of terms that are going to add together, namely xh and hx. They're one and the same. So let's go ahead and clean that up. It's going to be x squared plus, I'll go with the order xh. There are going to be 2 of them, by the way. And then the rest, plus h squared plus 3. That's about as far as this one goes for step 1. So that's only the first part of the numerator. Let's move on to step 2, where we're going to subtract the original function expression from what we just got in step 1. So in step 2, I'm just going to rewrite what we finished off with in step 1. That's x squared plus 2xh plus h squared plus 3. And then we have to subtract the original function's expression. Now, it's a good idea to use parentheses there because when you're subtracting something that has more than one term, there's some distribution that needs to take place. So I'm going to subtract the quantity x squared plus 3. And in the next step here, we'll go ahead and distribute and combine any like terms if possible. So this equals x squared plus 2xh plus h squared plus 3 minus x squared and then minus 3. You see anything that might combine or maybe cancel? Yeah, hopefully you do. The x squareds are opposites, so they'll cancel out. And then the 3's are opposites, so they'll go away. We can say bye Felicia to them. There's nothing else that cancels or combines, so we're left with 2xh plus h squared. Now on to the third and final step, where it says divide what's remaining from step 2 by, sorry about that. Divide what's remaining from step 2 by h. So let's take what we just got from step 2, that's 2xh plus h squared, and I'm going to set this all on top of h. Now here's where some more simplification happens. You'll notice that in the two terms above, each have a common factor of h. That's going to cancel out the h from the bottom. And you're probably thinking what the h is going on with all these h's. But anyway, I find it easier to break this up into two separate fractions. So the first fraction is going to be 2xh over h, and that's going to be added to h squared over h. And here we can definitely see these h's simplifying. So for instance, in the first fraction, they cancel out or divide out. We get 2x. And then in the second fraction, the denominator of h will cancel out one of the factors of h from h squared. So we are going to be left over with just one factor of h left over. And that's where the pain and torture, fun and excitement for finding the difference quotient with this function ends. Now I do have to give a couple of other remarks here. Number one, you'll know you're on the right track if the denominator of h from step 3 basically goes away. In calculus, what you're going to wind up doing is replacing h with 0, and obviously if we have h in the denominator still and we plug 0 into it, that causes issues for us. Okay, so if you're simplifying and in your final answer you have h underneath the fraction bar still, then something may have gone wrong and you'll have to revisit your work. The second thing is that the difference quotient answer really depends on the function you're working with. If we were working with a function, say, 5x plus 4, the difference quotient could come out to be different. So it's really just one of those things that are kind of situational, but luckily there's only one version of the difference quotient expression you have to work with. Other than that, you follow this 3-step process and you simplify as far as possible, and you will get your difference quotient. All right, so that's where I'll end it. If you guys have any questions for me, feel free to reach out. Otherwise, thanks for sticking through with another video of mine. Hope you got a lot out of it. And of course, let me know if you have any questions. Otherwise, thanks for watching, and I will see you in the next one.